we're going to add a new form of an equation. It's actually an old one, the standard form. It's something that you've seen before when we've written some equations or graphed as well, but we've never formalized it, which is what we're going to do right now. The standard form of an equation is in the form ax plus by equals c. There are a couple of restrictions here. A, B, and C must be real numbers. And then we'll skip to this third bullet here. Typically, there will not be fractions. You will multiply by the denominator or least common multiple of the denominator. Actually, the greatest common factor, the greatest common factor of the denominator to get rid of the fractions. So we typically won't see those. And in the middle here, A and B cannot both be 0 at the same time. So that means like A could be 0, but B couldn't. Or B could be 0 and A couldn't. So only one of them can be 0. And really, typically they're not 0. So that's where we're at there. We'll start by just giving you the equations of a couple of lines, and we'll write them in standard form. The next couple of slides, we'll actually write the equation and then put it in standard form. But we look here, this first one given to us is in slope-intercept form, y equals 2/5 x minus 3. And again, remember, ax plus by equals c is our standard form. So we have to get the x and the y together on one side. And our same skills that we've used all year, the inverse operations, is what we have to use. We have positive 2/5 x on the right, so we subtract it from both sides. We get negative 2/5 x plus y equals negative 3. Now, like I said before in previous slide, there typically won't be fractions. So we need to multiply both sides of this equation by this denominator, which is 5. We're going to multiply both sides by 5. So when we distribute on the right, these 5s will cancel here. We'll be left with negative 2x plus 5y equals negative 15. So that's one form of the standard form. There is one other for this, and that would have happened if we had multiplied both sides by negative 5, which would ultimately give us 2x minus 5y equals positive 15. And where that comes into play is typically you want a positive coefficient of x. I shouldn't say typically. I said sometimes you'll have a positive coefficient of x. So either one of these would be acceptable because they are integer coefficients and it is standard form. As we move over to the next example, I'm going to start by adding 5x to both sides. Now I know you might say, but our standard form is ax plus by on the left. Well, if 2 is equal to 2, it doesn't matter which side of the equation something's on. So we can switch that easily at the end. So we'll start with 11 is equal to 5x plus 1/2 y. And here, we still need to multiply because we have this fraction. What is the denominator of that fraction? Well, it's 2. We need to multiply both sides by 2. So 2 times 11 is 22 is equal to 10x plus y. So we can rewrite that as 10x plus y equals 22. And that would be the standard form of that equation. So that's what we have. All right, now we're going to start by actually having to write the equation of the line and then putting it in standard form. So we'll start back with much the same way that we've done some other things. I'm going to use the point slope formula here. Y minus y1 equals m times x minus x1. Because I need to get the equation of the line here first. So right now I have y minus 3 is equal to negative 2 times the quantity x plus 4. And it's x plus 4 because we had minus and negative in there. From here, it's the same steps as before. y minus 3 is equal to negative 2x minus 8. And I will add 3 to both sides, because again, we need that constant on the right. Y equals negative 2x minus 5. And we've gotten it into standard slope-intercept form, which is typically the first step as we need to put things into standard form. So now we have this. We have to get this x term, this minus 2x, to the other side. And in order to do that, we add 2x to both sides of the equation. And this one works out nice in that there's no fractions. We get 2x plus y equals negative 5 would be the standard form of that equation. So we need to, again, everything above that red line is something that we've been doing the last couple weeks. Now at the end, all we have to do is put this into a new form. That's all. So if we start over here, I'll go ahead and use the y equals mx plus b form, because I know some of you like to use that one. So we substitute in what we know. I have 1 here. My m is 3/4. My x is negative 5, and then I add b there. This one isn't going to work out quite as nice because we're going to have some fractions involved, but that's all right. We have 1 is equal to negative 15 over 4 plus b. We will add 15 over 4 to both sides to get our y-intercept. So 1 is 4 over 4, so that gives us 19 over 4 is equal to b. So that means we have y equals 3/4 x plus 19 over 4. I just went up top there to give us a little more room. Again, we'll need to subtract 3/4 x from both sides. And that would give us negative 3/4 x plus y is equal to 19 over 4. And the last thing we'll do here is multiply both sides. It's nice that the denominator is 4, but I'm going to use negative 4 just so we have a positive coefficient here. That'll give me 3x minus 4y is equal to negative 19, is the standard form of that last equation. So again, the process of getting something into slope-intercept form remains the same. We just take another step or two to get it into our standard form. That's all we have for today. We'll pick up with these tomorrow.